Hey, morning, Jaden. How are you doing? Congrats on the math student of the year. Pretty awesome. How was the online banquet yesterday? How'd that go? Oh, Spanish too. Dang. Yeah, I remember she really liked you. What do you call Spanish? Maestra? Is that Spanish teachers? Maestra? That sounds right. Oh yeah, test. That's the last AP test. You think you're ready? Wasn't really a banquet, it was just a list of people that won. Okay. Yes, I thought Maestra Reigns. I don't know if I'm saying it Reynes. You should be good. Well, the nice part is that you did the calculus, so you took a math AP already, so you kind of have an idea of what to expect. I got to imagine stats can be pretty similar format. It's just going to be statistics. So this kind of helps, right? You can take what you learned from calc and use it for stats. Yeah, most of these are tough. Hey, Jaden. Hey, Damon. Morning, morning. How are you, gentlemen? Jaden Fox, that logo on your Google gets me every time. Is that supposed to be Mike Wazowski with two eyes? I always know you're typing when I see that. So I know, Damon, you emailed me, so I know you have some specific questions. Uh, Jaden Dudek, I don't know if you do anything or if you just want to work on stuff. Just let me know in the chat. But Damon, if you can, um, specify which assignment you want to look at and review. Oh, man, energy bill came in. You guys will get to this age once you get bills. Worst feeling ever. Look at an email and you're all like, oh, okay, what's this? Then you see you had to pay something. Ugh, horrible feeling. Stay young. Stay kid. I have a question of the ALEKS assignment. One of the last four questions, they had the same type of question. I'm struggling with the two most recent ALEKS assignments and the most recent Okay, okay, cool. All right, so let's start with Jaden's question first, Damon. So open up 12.1 ALEKS. So, Jaden Dudek, they are a little bit different. The last 4 questions are 2 different types of questions. They might seem similar, but they are a little bit different. So maybe it'd be beneficial to go over one of each. So I'm going to pick one. I'm just going to take a look at it real quick first. Okay, cool. Let me change my screen so you can see this. Okay, so here's what I want you guys to do. We're going to do this question right here. All right, and obviously these are going to be just like your questions. So this is question number 6. So 4, 5, and 6. Questions 4, 5, and 6 are all like this. So you use this, as I go over this, this will help you with your problem. I'm just going to use this one because this is the information I have. So this is number 6. ALEKS 12.1. I'm just going to draw it on my paper right now, and you guys should do the same. So just draw that triangle so you have it. And we're looking for cosine of theta. Okay, let me go over here. Excuse me. Whew. All right. This is your problem. We want to find cosine of theta. Now, biggest thing to start, whenever we're doing these problems, not all the time, but most of the time, we need every side length. Right now, we're given 7 and 24, but we are not given this diagonal piece. We call that the hypotenuse. So the question is, do we need it? Well, remember, cosine of theta equals adjacent over hypotenuse. Cosine of theta equals adjacent over hypotenuse. Really important to know. And if we look at our angle, right, we have our adjacent is 7, so we're good with that, but we don't have our hypotenuse. I'm going to call it h. We don't know it. So I can't find what cosine of theta is without the hypotenuse. So I need to find the hypotenuse. So thinking to yourselves, okay, Mr. Harris, in class, what did we do? How did we figure this out when we're missing sides? And if you remember, I made a point that's saying if you have 2 side lengths of a triangle, a right triangle, you can always get the third no matter what. No matter what. Doesn't matter where the third missing side length is. If you have 2 of the side lengths, you can get the third. So I have 2 of them. I know I can get the third. How do I do it? Pythagorean theorem. So I take a squared, which is going to be 7 squared, plus b squared, which is 24 squared, is equal to c squared, which we called h. So h squared. Using my calculator, I'll just do it in my calculator. I trust you guys are going to be able to put that in your calculator. I get 625 equals h squared. The square root of 625 is 25. Remember this step here, how do I get from here to here? I just took the square root of both sides. Square root of both sides. Whenever you want to get rid of a square, so h is by itself, you would square root it. All right, now we take that information and we write what cosine of theta is. Adjacent side length is 7, so it's going to be 7 divided by hypotenuse we just found was 25. And that'd be your final answer. Cosine of theta equals 7 divided by 25. Just take a second, process it. Hopefully you copied that problem down. Because if you copy that one down and the other 3 that are just like this problem, you can do, it'll just be different numbers. It looks super easy when I do it, it confuses me. Okay, Damon, just make sure that you're following the steps. I think that's the biggest thing. Follow the steps. So all these problems have this format. Okay, you need a picture to start. In this case, they give you the picture, so you don't have to worry about that. You need to figure out what you're looking for, write the question. So in this case, it was cosine. You need to understand what the cosine identity is, which is the fact that SOHCAHTOA. Like how do we find a missing side length? We use SOHCAHTOA. You have notes on that. And cosine happens to be adjacent over hypotenuse. Now, if you don't know what adjacent hypotenuse means, we have to review that. But if you're clear on what adjacent hypotenuse and opposite mean, then you're good. And then after that, all you got to do is use Pythagorean theorem to find your missing side length. And then once you get your missing side length, you just plug it back in. So I'll go through all the types of questions, and then you guys can hang around and try to work on them your own if you would like. And I can just be here to check your work. Okay, so let's go over question 8. So let me switch back to my facing screen. All right, so we're going to use this problem. Question 8. So I'm just going to draw the picture that they give us. We got 10, we got 7, and we got theta. Okay, and we're finding secant, cosine, and cotangent. All right, go back to my camera here. So this is the setup you got. All right, so difficult thing about this question is just the idea of these new reciprocal functions. So if you remember, we talked about this throughout this week. Secant and cotangent are what we call reciprocal functions. And we got to figure out the reciprocal too. So secant means that's going to be 1 over cosine of theta. Now there's no really way for me to, unfortunately, just to help you memorizing those. It's just something that you have to memorize. So you have your notes. I mean, it's not too bad. You can just look back at your notes. But 1 over cosine of theta is equal to secant theta. And 1 over tangent of theta is equal to cotangent. In other words, the reciprocal of cosine is secant. The reciprocal of tangent is cotangent. And then cosine, right, we know what cosine is. We're good with that. So what we want to do is, to solve these problems, we want to start by just getting some basic trig functions. When I say basic, I mean we want to find cosine and tangent. We want to start with those. All right, so let's just start with cosine of theta. I actually don't need any work for this. Remember, I said earlier, cosine was adjacent over hypotenuse. So looking at this angle, the adjacent side length is 7, and the hypotenuse is 10. So bam, just like that, I can get cosine. Now there's no way for me to show you work on that. You just have to look at the triangle. Adjacent side length is 7, hypotenuse is 10. So you make your fraction adjacent over hypotenuse. If we can get cosine, that makes the secant very easy, because secant is the reciprocal. Remember, when I say the word reciprocal, it means flip the fraction. So all you do is you take cosine's fraction and you flip it. So if cosine is 7 over 10, secant is going to be 10 over 7. Bam, just like that. All right, so we're getting 2 of them without doing any work, just by looking at the triangle. Third one, we have to work harder. To get cotangent, it's 1 over tangent, so we need to find what tangent of theta is. I'm going to do it in red here. So tangent of theta is going to be equal to SOHCAHTOA, T-O-A. So it's going to be opposite over adjacent. All right, well, we have adjacent. We talked about that at 7. So check. We got that. Opposite, though? I don't know. I don't want to use O. I'll just put A. We don't know what that side length is. So we can't get cotangent of theta without tangent of theta. We can't get tangent of theta without the opposite side. So we need to find that. Mr. Harris, how do we find that? Just like we did before. If we have two side lengths, 7 and 10, we can always get the third. So we use Pythagorean theorem. We take small side length, 7 squared, plus other small side length, a squared, is equal to hypotenuse across from the right angle, so 10 squared. So I get 49 plus a squared equals 100. A squared equals 51. A equals the square root of 51. So now I can actually solve for tangent. Tangent's going to be opposite, which now we know was a, which is the square root of 51, divided by adjacent, which is 7. But remember, the question at the very beginning said, what's cotangent of theta? So if this is tangent of theta, cotangent is just the reciprocal. So you just take the fraction, you flip it. So I get 7 divided by the square root of 51. And those are my 3 trig ratios. And you can keep your answer as square roots or radicals in the denominator. So sometimes it'll be weird and it'll make you take the radical out of the denominator. ALEKS doesn't care, so you're fine with that. Mine has a sine place 2. Yeah, which is fine. You're gonna do the exact same thing. So you'll just do sine as opposite over hypotenuse. So you take your opposite side and your hypotenuse. I'm not really sure, but I'm kind of lost. Okay, Damon, that's fine. Just you gotta let me know what part, what step, where did you get confused? What do you know and what don't you know? So, like, for example, were you okay with what cosine, just finding cosine of theta? At the very basic level, was that okay? Jaden, my recommendation now would be to do your problems, and you can just do them while you're still on the stream, and then you can just put in the message if you have any questions or if you're getting something wrong, you need help. Because I think these were your only 2 questions you had. I'm good with finding the cosine of theta. After that, I just get confused. Okay. All right. So you get the first step is the cosine. That's good. That's 1/3 of the question. All right. So let me ask you this: how about the secant? How did we get the secant? Did you understand how we got there? So maybe just type in the chat. How did I get 10 over 7 for the secant? And why? What is the abbreviation of CEC? What is the abbreviation of? Maybe you meant to type an S there. If you meant to type an S, that's called cosecant. Yeah, it's probably CSC. That's cosecant. Opposite over adjacent. Okay, so this is what I want you to think about it, Dana. You're on the right. I like that the way you worded that though, because you're putting the pieces together. That's fine. It's just not the correct ones. So this is the biggest key. We have stuff that are called reciprocals. Reciprocals are when you flip the fraction. That's all a reciprocal is. So when you flip a fraction, again, this isn't something like I can teach. I mean, it's not something that I don't know how to word this, but it's just something you have to memorize. It's there's no trick or trade or anything like that. But the fact that you have to memorize that secant is the reciprocal of cosine. So these two kind of work together. The only difference is that the fractions will be flipped. So whatever you get for cosine, the secant will be the reverse fraction. So if I get cosine as 7 over 10, secant's going to be 10 over 7. If I get cosine as 15 over 5, secant's going to be 5 over 15. And it'll happen every single time. So again, I didn't have to do any work for that. I just knew that secant was the reciprocal of cosine. So if I can get cosine, I can find secant by flipping the fraction. That's how we get 10 over 7. And that's brand new. That's something we went over on Wednesday. So in your book, they wrote these down in chapter 12.1. So while you're doing this homework, it might be useful to have that page open. It'll tell you all the reciprocals. And then we use that same idea for cotangent. So cotangent was the reciprocal of tangent. So just like we did here, we had to find cosine first before we found secant. So just like that here, we have to find tangent first before I find cotangent. Tangent, just like, so you were good with cosine, I'm guessing you'll probably go with tangent then as well. Tangent is opposite over adjacent. The only issue is we don't know what the opposite measurement is. Remember, we have adjacent is 7, hypotenuse is 10, opposite, no clue. It wasn't given to us. So the tricky part is to find that we have to use Pythagorean theorem, which all the work is there. A squared plus b squared equals c squared. And then once you find that, you make your fraction, cotangent's the reciprocal. So you just take this fraction square root of 51 over 7 and you flip it. And that's how you get cotangent. And this one's a little bit easier to remember, their reciprocals, because tangent and cotangent, they both have tangent in the name. So that kind of helps a little bit. Okay, so I'm actually going to tell you guys, because I just realized this. I don't know what I was thinking. I never actually went over the Pythagorean identity. I never got to it. So I think my plan was, when I originally made it, was I wanted to get to the Pythagorean identity in our lesson, but I never actually got to it. So yeah, I'm not even going to grade that for accuracy. I'm actually not even going to grade that in general. So for the Khan Academy assignment, don't worry about it. I'll just put it that way. Don't worry about it. It's useful and something you're going to see next year, and it's something I wanted to get to, but I didn't realize we went a little bit slower on Wednesday than I was planning. And I forgot I needed to hit that, so that's on me. That's my fault. But hey, it's one less thing you have to do. All right, so Jaden, if you're still here, let me see. I don't know how many people are still here. All right, so Jaden might have left, or Damian might have left. Someone might have left, but whoever's still here, let me know what you need from me. What would be useful? What could I do for you? Okay, thank you so much. I thought I missed it. No, that's on me. I meant to. I was supposed to, but I just didn't. I wasn't moving as quick as I thought I was. So don't worry about it. Don't stress yourself out. It's not going to be a grade. So focus, Damon, on the assignments that you still have missing. Which, let me pull up real quick. The newest ALEKS, so definitely do that. You're probably working on that now. You just turned in 513, 1 through 3, I saw. So you'll be good on that. There is a couple more. I think you said you did the Khan Academy. So I'll update your grade with that one. ALEKS 8.4, you said you might need help with. And then some of the newer stuff. Okay, so I got to update your grade book, but what assignment would you like to work on now? Since you're here, we might as well work on some stuff. Yeah, you said you finished all the con. Okay. So we're good with the cons. There's a couple bookwork stuff and study guides, but let's focus on ALEKS right now. You think you finished 8.4, ALEKS? Oh, okay. That's good. Let me check real quick. I still have it as you haven't finished 8.4. So maybe right now, double check that. Need some help on 8.6, okay. Check 8.4 real quick. Tell me where you're at, if you're almost done, or if what's going on with that one. And then we'll talk about 8.6. Oh, wait, yeah, I just checked 8.4. So you did 8.4 or you didn't do 8.4? Oh, you're on questions. Okay, cool. All right, so yeah, you still got to do that then. Would you rather work on the rest of 8.4 if you need help with it, or do you want to do 8.6? You make the call, and then I'll help you out. Let's do 8.4 for now. Okay, cool. So All of you take a look at 8.4, number 6. Get started on it, and then if you get stuck, let me know, and I will help you. Well, I'm pretty good at finding the vertical and horizontals, but after that, I don't know what to do. Okay, so I'll tell you what. Type in the chat what your equation is. Or your function. What does it say? It says f of x equals what? -4 divided by x minus 2. Okay, cool. So let me ask you, what would be your vertical and horizontal asymptotes? So go ahead and type in the chat, what's the vertical, what's the horizontal? Vertical is x through 2 and horizontal. Beautiful. All right, so you did get those. All right, so you just plot those. So hopefully in ALEKS you're okay with that. There's buttons for it, so just do vertical asymptote. You do x equals 2, horizontal y equals 0. It'll plot it for you. The second part, all you need to do, Damon, is, let me show you on my screen in a second here. All right, go to Desmos. You start graphing. All right, so you'll go to your graph. You'll type in -4 divided by x minus 2. All right, so you have something looking like that. And then all I want you to do is click on this edit list up here, and then click on convert to table. Because the next part of the ALEKS question asks you to just plot 2 points and then graph. So what you want to do is you want to plot a point on this line, so like 1, 4, and then you also want to plot a point down here. So like for me, I'm going to have to add another value, so let's just do like 6. So you're going to want to plot that point and then plot that point. And I think start by drawing, then plot 2 points each piece of the graph. Yeah. Okay. Oh, okay. So sorry. Let me correct myself. You would need to do more than that. You would have to do um, this point and then maybe pick like, I don't know, 7. So you'd have to plot 2 on each line. So 1 and 4, 0 and 2, 6 and -1, 7 and -0.8. All right, so those could be your 2 points in each line. And you use like the plot feature in ALEKS. And then you're done. Click the graph function. And that's it. All right, so try that, and then in the chat, let me know if that works for you. Yep, okay. Yeah, so just pick 2 points in each. So yeah, the key, Damon, is you're going to want to make sure you're choosing points that are on both graphs. So you might have to adjust your table a little bit to get more points. All right, cool. So you should probably have gotten that one correct then. Seven's going to be the exact same thing. So I'll let you do 7 by yourself right now. It shouldn't take you too long. If you get stuck, let me know. I got number 7 correct. All right, cool. Moving on then. Let's check what number 8 is. So number 8's very similar. There's one little difference. It's just now we're going to have x's in the numerator and denominator. So yeah, you're gonna keep doing what you're doing. Nothing changes too much. There's gonna be one big difference though. So I'll let you try and then see how you do. I got number 8 right, and I figured out what changed. All right. So let me ask you then, what changed? What was the one little difference? So in Desmos, the last line would say number and then say undefined, but on 8 it didn't. This time you had to put a negative sign in front of a number. Okay. Yeah, so the big thing with 8, so in the last line would say number and then this undefined, but on 8 it didn't. This time. Yeah, so the biggest thing with these problems, let me show you real quick. Um, I think I gotta probably pull one up. So if you look at this, Damon, like look at mine. This is so the vertical asymptote's the same thing you've been doing. You can see it on your graph when you graph it, but also you set the denominator equal to 0. So negative x plus 2 equals 0. Subtract 2, divide by negative 1, x equals 2. So you can find that pretty easy. That's the same process. Nothing changed there. The numerator changes, though, now that has an x in it. So to find the horizontal asymptote, we want to look at what's the variable numerator and denominator. So we have an x in the numerator, x in the denominator, which means they have the same power. So this is x to the first, x to the first. So if you want to find the horizontal asymptote, you just take the fraction in front. So 2 divided by negative 1. So that was the big difference. Before, it was just the denominator was bigger, so it turned to 0. In this case, they're the same. So you take the coefficients out front. So that's what really changed with that problem. And then the next one, your last problem, number 9, is going to be the same thing. So you should probably be okay with that as well. All right, way to go, Damon. All right, so submit that assignment. You're all set. I'll double check that in ALEKS, and you'll get full credit for it. So, Damon, your grade is looking much better. Right now, you're currently, it says D, but you're currently at a C in the class. And I think you turn in a couple more of these assignments, I think you'll get to a B. Oh, wait, actually, I apologize. No, sorry, you're at a B right now, I think, with the new grading scale. So the new grading scale is, I think, 60 to 80 is a B. So, yeah, you're doing great. Keep it up. You might be able to get to an A, honestly. I think we can get you to an A. So I'll tell you what, we got 12 more minutes. You want to work on maybe a question or two from 8.6? Yeah, absolutely. No problem. Yeah, let's give it a shot. All right. So let's do 8.6. I don't know if you've started it at all, if you have any of it done. But let's double check that. And I appreciate you putting all this work in, Damon. It'll pay off. I really do. I'm proud of the effort you've been giving because a lot of people haven't, and this is a very tough time to give effort. So for you to do this, it shows you're very responsible. I commend you for that. Oh, you finished 8.6. Did you submit it? Oh, you did, didn't you? Yeah, you're good with 8.6. Nice. Okay, I forgot about that. All right, so that means that the only one left, right, is the newest one, right? This week's 12.1? Yeah, 12.1. All right, so yeah, last 10 minutes, you want to work on 12.1, I can help you out. I think that might be the best option. All right, cool. Now for 12.1, I'm going to need to take baby steps. So if you'd like, you can help me with 1 and 2. Then okay, that works for me. Baby steps are always good. Okay, so this is how it's broken down, Damon, is 1 through 3 are all the same type of question, 4 through 6 are all the same type of question, and then 7 and 8 are the same type of question. So we have 3 different types of questions. So let's start with the first type of question. This is 1, 2, and 3 will all be just like this. So I'll tell you what. Let's just do your question. So in the chat, tell me, tell me the side lengths. That's all I need. Just tell me the 3 side lengths on your question for number 1 or 2. Side lengths are 7/24. Oh, okay. So it's the same question I have. Perfect. All right, so let me just show you my screen. All right, so this is probably your question. A right triangle has the side length, blah, 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 blah. I'm going to draw it real quick. 25, 24, and 7. A is up here. All right, cool. So that's your question. Let me go to my notebook now. All right, so this is your horribly drawn triangle that you already have, though, on your screen. So what I need to find is I need to find sine of A, cosine of A, and tangent of A. All right, so let me hear you in the chat. What do you think? How do we find these? What principle should we use to get these answers? I've mentioned it quite a bit already today. If we're given the side lengths and we need to find what sine of A, cosine of A, tangent of A is, what do we have to use? SOHCAHTOA, you got it. You did spell it wrong. That's okay. You missed the H's. Everything else was good, just the H's. All right, perfect. All right, so sine of A is going to be the so. You think of so because it begins with an S, that's sine. So we're going to have opposite over, and then like you forgot in your spelling, H. So opposite over hypotenuse. Cosine is ka, adjacent over hypotenuse, and tangent is toa, adjacent or opposite over adjacent. All right, so I'm going to let you try. Let's just start with sine. What would your answer be? So remember, this is the angle we're looking at up here, this A right here. What is your fraction opposite over hypotenuse for that? You type that in the chat. All right, so opposite over hypotenuse. This is what's really important. What these mean. So you understand that SOHCAHTOA, so you know what that says. But we have to understand what opposite, adjacent, and hypotenuse are. So if this is my fraction, or sorry, if this was my angle, opposite is always going to be diagonal. So if I were to draw a line from that angle across, that's what we call opposite. So I'm going to just label this 7 opposite. So that means if O is opposite, 7 is opposite, I'm just going to put 7 in my numerator. So that becomes the numerator of my fraction. Hypotenuse is always diagonal. So opposite is diagonal from the angle. Hypotenuse is always diagonal from the right angle. All right, so 25 is going to be my hypotenuse. So that's where you get that fraction, opposite of hypotenuse. Adjacent, the way I see it, adjacent just whatever's left over. So 24 is going to be my adjacent. So maybe it'll help you, Damon. Each time you do this, maybe you should label each of those pieces. And then after they're labeled, you can then translate them to whatever fraction you have. So let's do the next one then. In the chat, let me know what's this fraction for cosine. Would it be 24 over 7? So adjacent would be 24. I agree the numerator. So adjacent is 24. But remember, it's adjacent over hypotenuse. So my hypotenuse is across from the right angle, which is 25. So it's actually 24 over 25. All right, you try the last one. Let's see if we can get tangent. Would it be 24 over 7? So opposite. Okay, so again, be careful. Or is that, okay, no, that was your answer for the last one. Sorry. So I still, yeah, whatever. What's your answer for tangent of A? Would it be 25 over 7? Okay, so opposite of, remember, so tangent is opposite over adjacent. So opposite of A is 7. So your numerator should be 7. Adjacent, we labeled as next to the A, which is 24. All right, so it seems like that's giving you a little bit of issues, which is fine. Now you have the answer for this one, so you can go ahead, type that in. You can submit that question. So you'll get that one correct with these answers. But I want to try. I know it's already 12, but if you have to, unless you have to be somewhere, I'll do one more problem with you. I'm gonna go a little bit over time. All right, let me pull up number 2. And then you tell me if this is the same one you have. So do you have that one? Then we'll end on this. This will be the last one for today. You can email me with any other questions. If not, we can get together next week at some point. I do not. Okay, so just type in what yours is then. What are your side lengths? And I'll try to just do yours. My side lengths are 5, 12, and 14. So I'm going to see 5, 12, and 14. Like this, Damon? And I'm guessing this is your angle. Okay. $13. 5, 12, and 13? Which 13 replaces what number? $12 is between A and C. $12 is between A and C. Sorry, Dave. I'm trying to figure out. 5 is between C and B. So I'm guessing it's going to be A, B, C, right? So 5 is between C and B. 12 is between A and C. Yeah, so that's right. Okay. And then what's the last one? 13? Jaden, I can't exactly help you because I don't know if we don't have the same one. So remember, tangent is opposite over adjacent. So make sure you have all the side lengths. If you're missing one of the side lengths, you have to use Pythagorean theorem to find the missing side length. And then you can find opposite over adjacent. So Damon, I'm guessing this was 13, right? I think you just accidentally said incorrectly at the start. All right, so Damon, you need to find sine, cosine, and tangent. Yes, it was 13 out. Okay, cool. All right, so um, let's just focus just on sine for now. Opposite over hypotenuse. So I want you to label in your triangle, Damon, or actually type in the chat, which side length is opposite of A. So opposite equals what? And then I want you to tell me what the hypotenuse is. So hypotenuse equals what? Let me add my right angle. That's going to help you. So what side length is opposite of A? What side length is opposite the right angle? Opposite of A is C. Oh, okay. So I think I'm seeing a little bit of the confusion then. So whenever I say opposite of the angle, what I mean is the side length. So these are points. A, C, and B are all points. So this is a point right here. That's point C. That's point B. That's point A. We completely ignoring those. We don't care about them. Those are completely irrelevant. They're not going to help us with this problem. It's just a way for ALEKS to describe the triangle. The angle at the point A is what we call angle A. Opposite of that angle is a side length. So opposite of angle A is always going to be a side length. Just like opposite of angle B would be a side length. So we're just working strictly with side lengths. So what side length is opposite of A? $12? Not quite. Because look, if this is A, 12 is right next to it. That's not opposite. When I think of opposite, it's like if I were facing you, Damon, like if we were in person, I was facing you, you would be opposite of me. We'd be facing each other. So I basically want to say, like, okay, what is facing this angle? Well, if I drew a line straight across, it would be that side length. 5 is what's facing A. So we call that the opposite side. So my opposite would be 5. Hypotenuse would be 13. I don't know if you meant, oh, okay, so 13 as the hypotenuse. The hypotenuse is what's facing the right angle. So if this is the right angle in that little box right there, facing it is 13. So 13 is my hypotenuse. So now I can label these opposite, hypotenuse, and then the one left over is adjacent. So 5 is opposite of A and 13 is hypotenuse. You got it. Exactly. Okay, so now that we got that, see if you can find cosine and tangent and type them in the chat. So cosine of A equals tangent of A equals. Well, I'm going to get off here, so I hope you have a great rest of your day, /week, and summer. I'll see you next year on the school. Jeez, Jaden, you're just going to end it like that? I think I might do a Zoom next week, Jaden. So I might do a survey sometime this weekend or early next week, see if anyone would be interested. I know DeGidio really wanted to. I know you mentioned it. So it'd be cool to talk to you guys, actually talk to you guys, not just over stream. And then it's not going to be any math related. It'll just be like a fun thing, just so we can talk about stuff. Thank you for liking the video, Jaden. Always appreciate it. Yeah, so, Jaden, don't be a stranger. Reach out. Come visit. Come say hi. It was a pleasure having you this year. It really was. I just realized my problem says tangent of V, sine V, and cosine of V. All right, so no different, Damon. Well, it is different, but what changes then is going to be these labels are all going to change. So, Damon, let's redo this then. What's opposite B? So what does opposite equal of B? And what is the hypotenuse of B? So these are all, ignore those. Well, I will get on Zoom for sure. Just send me an email or something for it. Yep, will do, Jaden. Appreciate it. All right, so this is your real question, Damon. So we're focused on this angle. You know what? Tell you what. There you go. That's our new triangle. 12:15. You're fine, Damon. I'm just trying to help you. If you have to go, you have to go. I would just like to. I like a little reassurance that you're following what these opposite, hypotenuse, and adjacent are. So if you can just tell me what that is in chat. Opposite of B is A. See, that's the key. Remember, like I said, opposite is always a side length. So opposite B is going to be the side length opposite of B, which is 12. Hypotenuse is going to be opposite of right angle, which is 13. And adjacent is just whatever's left over. So I would recommend, Damon, if you can rewatch this, but if not, email me or look online. Just look up like SOHCAHTOA explanation or video of SOHCAHTOA, because it seems like that's what's getting you most confused is the opposite and hypotenuses. Hypotenuse, whatever. Opposite is 12. Yeah, exactly. All right, well, I'll let you go. I know you got to get going. I appreciate you stopping by, Damon. Seriously. I think your grade is currently at an A, so you're doing fantastic. And all you need to do is complete 12.1, and then you'll be set. Great job. Great job. Like I told them, I might do a Zoom next week for Algebra 2. I don't know yet. I'm going to kind of get some feedback from people. You're more than welcome to join. I'll just take a look at Google Classroom, and I'll post something in there. Okay? So I appreciate, again, your effort. Awesome job. I'll be seeing you around. Wait, what is 8.6 study guide? It was posted in Google Classroom. So you can go to assignments in Google Classroom under 8.6. There's a link or attachment there. Yeah, there's an attachment in Google Classroom. So you click on that. I did that during class, a lot of it during class one day. So you can find that stream. I don't remember which day. Look at the calendar. Find that stream and you can get a lot of the answers. And then, yeah, just write it on a piece of paper and submit it. All right, well, I'm going to get going. Have a great rest of your weekend, Damon. Yep, you too. Thank you.